Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm very happy about this and I'm glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. So this is question 3243, shortest distance after road addition queries 1. So you're given a matrix of queries and basically you have a unidirectional road and you basically want to find the shortest path from 0 to n minus 1 after each addition. So after each iteration, you're going to find the shortest path and you're going to record how many edges are visited in that shortest path in each iteration. Cool. So let's first build the graph because we're going to need edges and nodes. And from the start, initially, you're going to have a road from I to I plus 1, not including n minus 1. So for I in range up to not including n minus 1, the key is going to be I, and then we're going to append the source to the destination. Cool. So now let's go over each source and destination in queries. And at each iteration, let's go ahead and add the source and the destination, right? Okay, so now for the current iteration, what we want to do is run a shortest path from 0 to n minus 1. So you can just use Dijkstra's. And we're going to start with the cost, and then it's always going to be 0 because we're starting at 0, right? And so while this queue is not empty, we're going to run a BFS, and let's heapify the queue so we can get the shortest path, because this is going to be the cost, or in this case, just the number of hops or edges that takes, because we're going to visit this, and then from this, we're going to visit that, and then from that, we're going to visit this until we get to n minus 1. So 5 minus 1 is 4 in this case. And so let's call this the actual hops and the node, and we're going to heap hop from queue. So that's going to keep this in sorted order and then this in sort of a binary search tree fashion. So cool. And then we also need a set called scene to not revisit nodes. So if node is in scene, then we continue. So we don't run this into an infinite loop. Otherwise, we add the node and then we visit that node's neighbors by visiting that hash map's keys values. And then we're going to heap push, again, in sorted order onto this queue based on the actual hops plus 1 and then the node value itself, right? So that's going to be the actual neighbor itself, because this is only a 1D list, it's not a 2D list. Cool. So when we ever get to a node, if the node is ever equal to n minus 1, then let's just go ahead and print the cost or the hops, because that's going to give us the shortest path because we're exploring layer by layer, right? Cool. And in that case, we can just break it because we've already found the best answer. This Dijkstra's algorithm is a greedy approach. So cool. So in that case, we can just record all the answers. We're going to append the hops, as you can see there. It matches with what we see. And then at the end, after each iteration, we can just return the answer after each iteration of the queries. So let's run this. Okay, submit it. And output limit exceeded. We need to get rid of these print statements. Let's submit it again. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for question 3243.